beautiful Morning Glory pool located near Old Faithful. There's a lot we can learn from pools like this, including how both humans and past climate can influence Yellowstone's hydrothermal system. Now, Morning Glory used to be a beautiful blue color. But over time, that color changed because being near the road that was the entrance to Old Faithful, people would stop by and throw things in like coins and trash. It lowered the temperature of the pool and allowed different kinds of microbial communities to grow in the pool, changing the color from that blue to the rainbow color that we see today. Morning Glory is also a place where you can find travertine. You may know travertine is something that kitchen countertops are made out of. It is a hydrothermal form of limestone, kind of a hydrothermal calcium carbonate mineral. Now, travertine is not forming anywhere in Yellowstone Caldera today. It is forming outside the caldera, for example, at Mammoth Hot Springs, where it makes these beautiful big terraces. The fact that travertine formed at one time, though, suggests that climate might have been different. And in fact, when we date the travertine at places in the caldera, it corresponds to times when Yellowstone's area had a much wetter climate. So the hydrothermal system actually would respond to different climatic conditions. And this is actually true also of times of drought, when we have evidence that geysers like Old Faithful and Steamboat actually stopped erupting. So we actually see really strong responses to Yellowstone's hydrothermal system due to changes in climate, whether it gets wetter or drier. So that's the story of Morning Glory. Now let's talk about earthquakes, ground deformation, and geyser activity over the past month.
Well, once again, not a lot of seismicity to report in the Yellowstone region. The University of Utah seismograph stations located just 72 earthquakes during the month of June. The largest was a magnitude 2.5 that occurred on June 10th, just to the north of Yellowstone Lake. There was also a small swarm of about 29 events that occurred between June 6th and 9th, just to the northeast of West Yellowstone, Montana, and it's part of that band where we see most of the seismicity in the region that extends from Hebgen Lake into the central north part of Yellowstone National Park near Norris Geyser Basin. So background earthquake activity for the month of June. Turning now to ground deformation. This is vertical deformation at the Lake GPS site, which is on the east side of the caldera. Each one of these blue dots is 1 day of data. Downward trends indicate subsidence, upward trends indicate uplift, and this plot spans the last 2 years. We have an overall trend of subsidence which has been ongoing since 2015, and it's interrupted in the summer months by a pause or even a little bit of uplift caused by seasonal changes in snowmelt and groundwater. Now, we haven't seen a lot of deformation over the last month, so we may be starting to go into that summertime change in deformation, but overall, no real changes in the patterns of ground deformation in the Yellowstone region. And finally, looking at the tallest geyser in the world, Steamboat Geyser, that erupted at the end of May. And as you can see from this plot of temperature, and this is measuring the temperature in Steamboat's outflow channel, we were just getting daily temperature variations because the geyser wasn't doing a whole lot. Sort of the middle of the month, we started seeing more variability, and that's a sign of minor eruptive activity. So we're seeing more minor activity at Steamboat right now. That suggests that we will culminate in another major eruption, perhaps sometime in the next few weeks.
Well, that's the monthly update from the Yellowstone Volcano Observatory. If you enjoyed this, please hit like and subscribe down below. And if you have any questions at all, either leave us a comment or drop us a line via email, yvowebteam, all one word, @usgs.gov. Thanks for joining us, and we will see you next month. Bye-bye.